Hello, everybody. When you're programming right at your conceptual limit, all the rules of clean coding tend to go out the window. So I just wanted to remind you, because the whole idea of clean coding is it's supposed to help you think about your program in a better way. So I just wanted to highlight a couple things I've been seeing in people's code. So the first is there seems to be a lot of confusion about what are fields of an object. So I've seen a lot of people actually create their forest variable inside the constructor, but that's not the job of the constructor. If you do it here, it's called a local variable because it means that the variable is locally defined only inside the constructor. So what that would mean is that this same variable stops existing as soon as the constructor is done running. So it's not a variable that your object has. It's a temporary variable that gets created in the constructor and then destroyed almost immediately. So what you want to be doing is you want to be defining your fields above the constructor. And this should be familiar from last year whenever you create objects, right? The fields are the list of facts that your object knows about itself. So the problem here is I've also seen several people declare their variable correctly at the top, but then immediately try and assign it a value here. But the problem is you don't know what size you want the forest to be until the constructor runs. So R and C don't have a value up here. So the solution is the conventional pattern for any object creation. You define your variables up here, the fields of the object, but that just says what types of variables are you going to need? What are all the facts? The whole job of the constructor, and in fact what it even means to construct an object, is to give all of those fields their values. So that's always the division of labor. You always declare your variables but don't assign them, and then the constructor actually assigns them. Okay, there continues to be questions about static methods, which I totally get. We haven't really talked about it very clearly. So let me do another run at this. The code on the left here is how I imagine using the simulator object. It's like I've got some main method somewhere. I'm creating a new simulator with the size of the forest, and then immediately I'll tell that simulation to initialize its forest, maybe to some density. So you'll notice that the init forest method is being run by the sim variable. So it's an actual simulator object that's running the method. In order for that to be possible, your method can't be static, because what it means to be static is that the method runs without any objects at all. Because what it means is that the method is run by the class itself, not by any objects. So if you have a method that needs to interact with the fields of a specific object, by definition it can't be static, because static methods don't have objects. They're not owned by objects, they're not run by objects. And a lot of people have creatively gotten around this problem by having their static methods take an input and give an output. But that should be like a clue to you. Like, why is it that your static method can't just access forest? Why do you have to pass it in as an input and give it as an output? The reason is because it's static. So if you remove the static, now you don't need an input and you don't need an output because your method can just operate directly on the field of the object itself. So this is a little bit more proper. So here we've got a init forest. It takes a density as an input because that's the density we want to initialize it to. And it doesn't return anything. And the code on the inside can go ahead and freely use the forest field up here. And then the way that we use it in a main would be you create your simulator and then you just ask your simulator to initialize itself to a particular density. So that feels a lot better. A lot of people are forgetting the naming rules. So if they're constants, they need to be declared as static final, and they need to be named with all uppercase. Any other fields have to be marked private. So this on the left feels very bad to me, and this on the right feels very good. I'm seeing some magic numbers in a variety of places. If forest equals 1, then make forest equal 2. What in the world does that mean? Oh, if forest is a live tree, then replace it with a fire. That makes a lot more sense. So we made those constants at the top of the class for a reason. So just double check your code and make sure that you don't have any floating magic numbers. So the last thing is a big structural thing. I'm seeing a lot of people write methods that do like a whole lot of stuff inside one method. So for example, look at this constructor. The constructor is doing like 3 things. it creates the forest, then it fills it with trees of a particular tree density, and then it finds a tree and sets it on fire. It's true that you probably want to do all those things in that order, but you don't want the constructor to do all of those things. And the reason why is, there's a couple of reasons, but the main reason is it makes your program less flexible. This is a little bit better if you broke out the initialization and the setting of the fire as their own methods. Now at least the constructor reads a little bit better. You create the forest, you initialize it, you set a fire. That's pretty good. When you create a new simulator object, you have to tell it the initialization density, and that's okay because we still have an init method, so you could reinitialize it to a different density if you wanted to. So that means that you don't have to throw out your simulation object every single time you want to run a new experiment with a new density. Instead, you can keep your object, but just tell it to reinitialize itself with whatever your new density is, and that will be just fine. The main problem here, in my mind, is that it doesn't make it possible to create a forest without a fire. Like, you're forced to make a fire every time. And that just feels a little bit less flexible to me. So my favorite version would look something like this. On the left here, all the constructor does is initialize the forest array. Then you have the initialization and setting fire methods available. But you let the person using the simulator class decide when to do those things. So for example, on the right-hand side, here's an example of what it might look like to use. So you could create a simulator, and then you could loop up to max trials, and you could initialize to a certain density and set a fire, and then run it until eventually the fires burn out, and then get whatever information you wanted about the simulation, and then do things with the results, like presumably calculate an average. And then when you loop back up to the next trial, you reinitialize, reset a fire, and so on. So to me, that feels very flexible. And the general kind of idea at work, the big design principle at work, is that you want to identify what are the simplest, most atomic actions that your simulator needs to do. And each one of those is a method. And that's what I mean. Like, each method should do one thing, and the thing should be pretty simple. And then if you want to, you can start stringing those simple actions together. And you could even make your own method inside Simulator, whose whole job is to string several basic actions together. But the point is, if you break it down into basic actions, that gives you the flexibility to combine and recombine those commands in different ways if your purposes change a little bit for why you originally wrote the code, which happens all the time in programming. If instead you had kept everything inside one giant constructor, now you're very limited, and later on you'd probably find the need to actually break this out into its own method. But it's better if you do it to begin with so that you don't have to go back and ask yourself, what code was doing this? Oh yes, now where should I put it? Like that. So I hope that this was helpful. Please clean up your code a little bit if you're able, and I hope that it will help you think about it better.